This problem wants me to solve the rational equation, which means I need to find out what values of x make this true. So first of all, I'm going to solve this addition on this side, which means I need to make the denominators the same. So I'm first going to have to factor this one to see what's missing so that the denominators can be equal. Okay, so let's go ahead and factor this. I need 2 factors of 8 that add up to 6. So that's simply 4 and 2. So now I'm going to replace this denominator with these 2 factors. Now you see I'm ignoring this right hand side here because I'm just going to focus on the left for the moment. So we're just going to leave it there by itself and it can watch what we're doing. You can see that there's x plus 2 on either side, but there's no x plus 4 over here. So that means that I have to multiply this term by x plus 4 over x plus 4. So just looking at the numerator, that's going to give me x squared plus 4x plus x plus 4 all over x plus 2 x plus 4. Now once your 2 denominators are the same, you can write it as one expression over one denominator. So I'm just going to add this expression to the numerator and see how these are the same. I'm just going to replace it with one denominator. So you can see now we just have one numerator and one denominator. I'm just going to neaten the numerator up a bit by collecting like terms. So I've got x squared, I've got 4x and x, which is 5x, and then I have 4 and 3, which is 7. I haven't changed my denominator, so that's still x plus 2, x plus 4. Now I can't do anything more with the left-hand side, so I'm just going to bring the right-hand side back in that we've been ignoring. And now we have to make these 2 denominators the same. X plus 2 exists in both denominators. However, x plus 4 is missing from this side, so we're going to have to multiply it by x plus 4 over x plus 4. So I've just rewritten the left-hand side because I'm not doing anything with that at the moment. So now I'm going to multiply this. It's just being multiplied by 1, so it's only going to be x plus 4. And then I'm going to have x plus 2, x plus 4 on the bottom, and this is exactly what we want. Because now that both denominators are equal, we can ignore them and just equate the numerators to solve for x. So I've just equated the 2 numerators. Now I'm going to bring everything over to the left-hand side. So I'm going to subtract x there. So I get 4x. There is no x squared term on the right-hand side. So x squared stays as it is. I'm also going to subtract the 4. So 7 minus 4 is plus 3. And that's going to equal 0. So now to find x when something is equal to 0, we're just going to factor. So I need 2 factors of 3 that add up to 4, and that's just 3 and 1. So we end up with x plus 3, x plus 1, all equal to 0, which means x equals negative 3 and negative 1. However, we do have to bear in mind any restrictions on x. Now to determine the restrictions on x, we need to have a look at our denominators. We've got x plus 2 and x plus 4, and they can't equal 0. So we need to ask ourselves what value of x would make this equal 0? And the answer is negative 2. And then we need to ask ourselves the same thing for x plus 4, and that's going to be negative 4. And as both denominators are the same, they are the only 2 exclusions. So x equals 3 and x equals negative 1, they are both absolutely valid. So they are indeed our solutions.